In this tutorial, we will discuss yet another type of infinite series. In the previous videos, we have already discussed about the rule of diagonalization for the given series. Where f of n can be any function having polynomials with integral powers of n, as shown. Now, we use a new rule, which I call up-down shifting rule for the infinite series of this form, where f of 1, or the first term is always considered 1, for our convenience, and f of n can be any function like geometric series, where each term is a factor multiplied by a previous term, or it can be any series, where each term is dependent on previous two terms, for instance the Fibonacci numbers. In general, saying implicitly, f of n depends on previous terms, and saying explicitly, f of n is a form of exponential function in itself. You needn't get worried seeing the constants used here. The interesting part is that f of n can be anything, either a known sequence, or a function, with random numbers which we may not know anything about it at all. So, what you can do is simply use this rule whatever be the value of f of n, you won't go wrong. The only thing to be noted is that the first term should be 1 and the series should converge, and since we are using x as a variable, we assume that the value of x is such that the series converges. Let's proceed with an example. For the given problem, the common approaches that can be sought for are the binomial expansion or the Taylor's series, but either method consumes a lot of effort and time. I have used the technique of binomial expansion to get this up-down shifting rule of finding the sum of series, which involves only simple calculation and is easy with many application in series. Before using this rule, the question is, can we use rule of diagonalization here? Let's extract the coefficients in variable x, and take consecutive differences between them. Note that you can never get a common difference in this type of sequence in spite of going to several steps, hence we don't use rule of diagonalization here. Before using the up-down shifting rule, check whether the first term is 1 or not. If it is 1, it's okay. We have already talked that the series is assumed to be convergent, and despite knowing nothing about the sequence, we can apply this rule. The main principle of this rule is shifting the numerator into denominator or vice versa. First, extract the coefficients of the variable, or the constants that appear in front of variable as shown. Next, put 1 as shown. Then change the sign of second term and put it down as shown. Then, multiply the terms shown, 1 and -1, and add the next term which is 2 and get the result as 1. Then, put the result down by changing the sign. Similarly, multiply the numbers linked by the line and add them. The result so obtained is added to next number and is put down by changing the sign. Apply the same process and shift the numerators into denominators one by one. You can easily remember the multiplying pattern. Just look at how the cross pattern is formed while multiplying. Now, put the variables in the values both in the numerator and the denominator as shown. Finally, get the answer by shifting the denominator as shown. I have used Fibonacci sequences in the series, hence on simplifying it reduces to given expression. Not only this rule gives the infinite sum, but it also gives the recurrence relation of the terms in the coefficients. Let's look at the denominator we obtained. We can simply replace 1 with nth term, x with n minus 1 term, x squared with n minus 2 term, and so on, and equate with 0 to get the recurrence relation. Concluding, we found the infinite sum of given series using up-down shifting rule. Meanwhile, same rule is applied to get the result backwards also. We also found the recurrence relation for the coefficients by simple replacement. So, if we know any one of these three expressions, we can easily find the other two expressions by this rule.